All right, here we go. Let's do the proof for the formula. It's pretty easy, actually. It looks scary, but it's actually really easy. Here's your general quadratic equation. Y equals ax squared plus bx plus c. You're asking to find x-intercept. So how do you find x-intercept again? You let y equals 0. So I'm going to let y equal to 0. So that means this letter y, I'm going to let it equal to 0. Then it presents a problem. You've got ax squared plus bx plus c. You're trying to solve for x. But having two x's is not ideal. And usually you would use cross method or grouping method, but the problem is you don't know what a, b, and c is. So that leaves the second method. What's the method if you can't do cross and you can't do grouping? What's the leftover method you got? Complete the square. But you can't complete the square if the coefficient in front of x squared is not 1. So we need it to be 1. Now right now it's a. So how do you get rid of that a? What do you have to do? Take it out as a factor. Very good. So take out a. So write this down. Take out a as a massive factor. So take it out. A times what will give you ax squared? X squared. A times what will give you bx? Now be careful there. Bx over a. Very good. This is now b over a. So if you think about a times b over a, the a's will cancel out and you end up with bx. What about the last one? A times what will get you c? C over a. Very good. So this, now, the coefficient of x squared is 1. Now you can complete the square. So here, let's complete the square that you learned from exercise 5I and F. Complete the square. Remember the b term is b on a, so the middle term. What do you have to do again? You half the middle term to get what is inside the brackets. Right now you got b over a. What's half of b on a? Think about it. b over a, half. Yeah, b over 2a. So remember half of the b term, so it's plus b on 2a. So that's what's in the brackets. Now if that's your bracket number, what's the last number meant to be? Very good. You got to square this one. Square this one to get that number that you want. At the moment I got c over a, which is not what I want. I wish I had b squared over 2a squared. So let's work it out. What's b over 2a squared? When you add it, you got to subtract it. Here we go. So we're almost there. Have a look. This is a perfect square, like we've been practicing. That's the leftover bit that you've been practicing. Let's work it out. What's b over 2a squared? What's b over 2a squared? b over 2a squared just means b over 2a times b over 2a. So if you can see that, b times b becomes b squared. 2a times 2a becomes 4a squared. So over here, this is the leftover. So I'm minusing b squared over 4a squared. This is a nice perfect square because I'm doing completing the square. There we go. That's my perfect square. Yeah. Now, up to this step, remember, what are you trying to solve again? Don't lose your track of what you're trying to solve. What are we trying to solve for? X-intercept, which is this one. So how do you do it? You got one x now. The best way is just to do inverse of everything to just get x. Because there's only one x, so that's less of a problem. Before we had two x's, so that was problematic. But now this is less. We just undo everything. That right there, that's a times all of this. So instead of times a, I can get rid of times a by dividing. Divide both sides by a. A's cancel out. 0 divided by a gives me 0. I get this nice quadratic equation here. X plus b over 2a all squared minus b squared over 4a squared plus c over a. Looks complicated, but now you just move everything across. Move this one over here, subtract both sides, add both sides, square root both sides, and then bring this over, and that's how you get. That's where the formula is coming from. So let's do it. Let's break it apart. So if I want to get rid of this plus c over a, what's the opposite of plussing c over a? minus. So here I do minus c over a minus c over a. How do I get rid of minus b squared over 4a squared? Add them. So here I say add b squared over 4a squared. That cancels out, this cancels out. So then I have to add this side, b squared over 4a squared. Let's write that out again. So I'm just going to write it out a bit cleaner down here. This now gives you negative c over a plus b squared over 4a squared is equal to x plus b over 2a all squared. Getting rid of square, what's the inverse of squaring? Square root. But what do you have to be careful when you square root? Plus or minus. So this cancels out. Don't forget there's a plus or minus answer there. Now, that fraction, notice in your formula, it was actually just one nice fraction. The reason why is because you can actually separate them. Let's separate them. Here. Let's work it out. If you're working the fraction, how do we combine this to make one fraction again? We've got cross method. Do you remember cross fractions? You can do like that. There's a quick way to add same denominators, or if you want, times this by 4a on the bottom, times the top by 4a, so that you have the same denominators. So that becomes 4a squared on the bottom, so 4a squared. This one becomes negative 4ac. Can you see where it's coming from? Negative 4ac. That's your b squared. No worries. That's what we were saying before in the formula. B squared minus 4ac. I've got it. It's there. But remember, we're square rooting. I can't square it at the top, but I can definitely square it at the bottom. Because that's timesing, not plussing. There's only one term there. If you square root the bottom, so the top I can't square root. Top I can't square root. It's b squared minus 4ac. What is the square root of 4a squared? 2a. That's where your 2a is coming from. Yeah, because the square root of 4 is 2, and square root of a squared is a. Yeah, so I'm just simplifying this side over here for now. Let's put it all together. I'm saying once you square rooted both sides, on the right side you've got x plus b over 2a. The left side, we've simplified it to square root. Remember, plus or minus? B squared minus 4ac all over 2a. And you're almost there. Bring this one across now. How do you get rid of plus b on 2a? Minus. Minus b on 2a. Minus b on 2a. But since they both have the same denominators, you can combine them together. And that's how you get x is equal to negative b plus minus square root b squared minus 4ac all over 2a. But you can see the technique that we're doing. It's the same technique that you would have done had there been numbers. All I did was complete the square and then inverse operations. Yeah, I literally rearranged just the way you would have done in 5i. You would have completed the square and then just let it equal to 0 and then move everything across. That's what I did. And that's where the proof comes from. So that's a formula to find the x-intercepts. But yeah, there's a bit of fractions, a bit of algebra to get used to. That's why with the mainstreamers, I normally don't teach that. But with you guys, I thought it's pretty good for you guys to see if you can keep up with it. All right, I'm going to stop the video. That is the proof